Geometric distribution is a distribution of pretty much trying how many times distribution of how many times you try until you success. The success rate is p. So pretty much is of n minus one time of failure and one time of success. One of the important property to remember of this geometric distribution is memorylessness. So meaning the probability of trying 5 times after failed 2 times of the condition of failing 2 times is equal to probability of success after 3 times, because the probability, those are independent events in the sense that it's not dependent on the past success or a past failure. The rate doesn't change. That, you know, it's happened a lot on dice, poker, or whatever. Sorry, on dice and like lottery and stuff. So for using that property, we can actually look into the expectation value. This can be just 1 plus x minus 1, and you got this. Since this can be divided into 2 scenarios, one scenario is x equal to 1, because x is going from 0 to infinity. So it has x equal to 1 and x greater than 1. So pretty much you can consider this is just under the condition of a success. You success on the first run, p. Since you x equal to 1, then 1 minus 1 is 0, so expectation of 0 is 0, so this 1 is gone. So after the first term, if you have first time failed because x greater than 1, so you have tried more than one time, this is the probability of failing 1 times. And this looks familiar of this, the memorylessness. So actually e to the x equals e to the x minus 1 greater than, under the condition. So under the condition of you already failed 1 time, and how many times it will take more is exactly the same due to the memoryless property of the geometric distribution. You have, so pretty much substitute back in ex, this become ex, and then we have pretty much ex equals 1 plus 1 minus p ex, and it's pretty much p ex equals 1, thus ex equals 1 over p, which is this. Similarly, we can do the same thing for expectation value of x squared. Is x equal to 1 and x greater, probability of just trying 1 time and succeeded and trying more than 1 times. So this is 1. Then there's the expectation of 1 is 1. Then it's p, this 1 become p. And this, because this is failed rate, so 1 over p. And since remember the expectation value thing here, then this essentially become trying x plus 1 times equals to this. And using the property of that to make into 3 different terms, ex squared, 2ex, and 1. And we know what EX is. EX is 1 over P. Yes, EX is 1 over P. And this is 1. This is 1. Substitute everything together and put e to the x square. Sorry, ex square on the on the left. We have p minus p, and there's 1 left here. It's 1 here, and it's 1 minus p over p right here. And then we get ex squared divided 2 on p on both sides. We got 2 minus p over p squared. And we can use variant of ex squared, expectation value of x squared and the expectation value squared, getting this variant, ended up getting, so we have expectation value 1 over p, variant 1 minus p over p squared. There's a video other people done similar things, and also I have other approaches to calculation of that. I will link this on the description.